allocation and use for here in the Harney Basin. For the last couple years, the department has been working with the Rules Advisory Committee to form the proposed rules that hopefully each of you grabbed a copy right in front of you there, sir. That's the proposed rules. We're going to be going over that today. Quickly, my name is Alexandria Scott. I'm going to be your facilitator for the evening. We'll do a round of introductions for water resources staff, and then we'll go ahead and get started with the presentation.
I'm Tim Seymour. I'm the assistant manager for groundwater at the Water Resources Department. I'm based out of Pendleton, Oregon.
Hey everybody, I'm Jason Spreet. I'm the East Region Manager for Water Resources. I'm based out of Maple City.
Hi everybody, my name is Kelly Mines. I'm the rules coordinator / policy analyst for this process.
All right, now that we've gotten introductions going, I'm gonna turn it over to our first presenter.
Thanks, Alexandria. So to start from the beginning, in about 2016, the department was receiving complaints from water users in the basin about ongoing groundwater level declines. And at that time, the department undertook some rulemaking, designated the Greater Harney Valley groundwater area of concern as a restrictively classified area, so not allowing any new groundwater permits, with a few key exceptions in there in that area. And then at the same time initiated a groundwater study with the USGS, the United States Geological Survey, to study groundwater in the basin. And that study lasted about 6 years. It was a pretty robust process, collecting data, analyzing it, and producing reports. And today, what we're going to talk about is, at the start, why the rulemaking is needed, and that comes from that USGS study. We'll then dive into some strategy and tools about how we're going to try to solve that problem that was identified. And we've got a couple of three tools there we're going to talk about, and then we're going to get into a Q&A. So if you'll hold your questions to the end, we'll run through a bunch of information, and then you'll have the opportunity to ask questions, and we'll answer those before that public hearing. So if we jump to the next slide, Kelly, I want to dive into what that USGS groundwater study shows us. So the next slide, the first key point is that that basin study identified the Harney Basin hydrologic boundary as also the boundary for the groundwater reservoir, and that all groundwater within the Harney Basin is connected. There are no known boundaries to flow of groundwater throughout the basin. Now, that said, groundwater also exists in multiple connected geologic units. When I say geologic units, you can think rocks. So different types of rocks have different hydraulic properties. So how the water flows through them varies depending on the type of rock. More permeable rock allows water to move quickly. Less permeable rock, water moves much more slowly. And so that behavior of groundwater affects how water levels are displayed in wells across the basin. And then the last key point from this groundwater study that I want to talk about is that the rates and magnitudes of recharge, so water coming into the groundwater system, vary based on where you are in the basin. And then at the same time, discharge of groundwater, those rates and magnitudes also vary based on where you are in the basin. So some areas have higher discharge and some areas have higher recharge than others. And so that depends on where you're at in the basin. And when we talk about discharge, what I'm referring to is both natural discharge in the form of springs, stream flow, and then also groundwater dependent plants that are able to actually tap into the groundwater. And then anthropogenic or man-made discharge, right? So think pumping of groundwater wells. That's what we're talking about there when we talk about man-made discharge. So on the next slide, I want to dive into the problems we've identified. So as part of this rulemaking process, the department produced a groundwater report for this process. It's available on our website. You can read through it. But there were three key points that were identified. And the first one is that groundwater levels have declined excessively. And that is defined as there's 50 feet of total decline or more within wells in the basin. And so that 50 feet of total decline is from our highest known measurements in those wells. The second key point is that wells are excessively declining. So we have wells where we have water level records that show declines of greater than 3 feet per year or at least 10 years consecutively. And so we have that in the basin as well, two pretty serious water level conditions. And then the third point here is that the available groundwater supply is or is about to be overdrawn. And overdrawn is defined as a condition where pumping exceeds recharge. And the reason overdrawn is such a critical or concerning situation is that when all recharge is being pumped, that leaves no recharge to the groundwater system for those natural discharge processes. So discharge to streams and springs or groundwater dependent ecosystems and plants. And so that's those are the three key points and criteria that the groundwater study identified. And these are statutory criteria that then authorize the Water Resources Department and Commission to designate a critical groundwater area. And so that's why we've got them up here today, and we're going to talk about them just a little bit more in depth. So Kelly, if you want to go to the next slide. So first I want to talk about declined excessively. So as I said, that means that there's been decline of greater than 50 feet from highest known values. So here we've got a map of the Harney Basin. On this map are a number of red dots. The red dots represent wells where we have enough water level record and data to be able to identify that greater than 50 feet of decline has occurred. Some of these wells have actually crossed the 100-foot of decline threshold. So pretty substantial quantities of decline or magnitudes of decline in some of these wells. The other thing I want to point out is that our data and our water level record is not perfect for all wells in the basin. So there are many wells where we're not able to do this evaluation because we either don't have historic measurements or we don't have current measurements. And so we believe that if we had a more complete water level record, there would be many more wells on this map based on and showing that the conditions are not just unique to these individual wells. And then the last thing I want to point out is that we believe more wells are going to cross this threshold based on the current rates of decline in the next several years. So the problem is continuing. It is not slowing down. And so we believe that more wells will cross this threshold. We go to the next slide. I want to talk about excessively declining. So again, this is rates of decline of at least 3 feet per year for 10 years, at least 10 years. And again, we have a similar map, same geography, and you can see the yellow dots here show the wells in which we were able to have enough data to be able to make this determination and identify that we have at least 3 feet of decline per year for at least 10 years. And again, our water level record is not perfect, so we don't have data to evaluate in more wells than that. But if we had data, we believe that in many of these areas, we would see many more wells listed on this map. And then the last thing is, again, based on the rates of decline in these areas and the water level trends that we've been monitoring for the past decade, we believe that more wells are expected to cross this threshold in the next several years. So again, problem is not getting better, it is continuing. And so we want to address it. And then if we go to the last slide I have, talking about these criteria, I want to talk about overdrawn. So as part of the groundwater study, the water budget work where you calculate the amount of water coming in, the amount of water going out, which is what's necessary in order to calculate this overdrawn condition. The USGS broke the basin into three key water budget regions: the north, the west, and the south. And those basically match with the three main streams in those areas. So you've got essentially the Silvies, you've got Silver Creek, and then you've got the Donner and Blitzen. And then within that, they broke it into an uplands and a lowlands. And so you've got the colored areas are the different water budget regions. And then you've got this yellow boundary in here that squiggles around, and that defines the lowlands versus the uplands. So within that boundary is the lowlands. Now on the left-hand side here, I've got a table that outlines by water budget region the difference between recharge and pumping within the lowlands, and then also the difference between recharge and authorized use within that same area. So within that northern region, pumping exceeds recharge by about 2,700 acre feet per year. So we're clearly overdrawn by the definition. We're pumping more than is being recharged. And if we look at the authorized use, there's 96,000 acre feet of paper water right in excess of recharge. So if all that paper water were to be pumped in a year, we'd be wildly beyond the recharge values and wildly overdrawn. In the southern region, which is where we are today, recharge or pumping exceeds recharge by about 26,000 acre feet. And authorized use exceeds recharge by about 10,000 acre feet. And then in the western water budget region, which is that Silver Creek area, pumping or recharge exceeds pumping by about 4,500 acre feet. But we believe that this means it's about to be overdrawn because the authorized use would take us to an overdrawn value of about 18,000 acre feet. And that if all the paper water were to be pumped, would be about 18,000 acre feet more pumping than there is recharge coming into that lowland area. And so we have the condition where parts of this groundwater reservoir are overdrawn, and we have substantial groundwater level declines. And so we need to address that problem. And so I'm going to hand it over to Jason here to talk about some of the strategies and tools we want to use and are proposing to use in these rules to try to solve this problem.
Thanks, Tim. Right, as Tim said, we're gonna talk just briefly about some of the tools the department has, you know, at its disposal to try to address some of the problems. So there are three main tools the department can use under their current authority to kind of address this problem. The first one we'll talk about here in a bit is the classification process, and the classification is a strategy to try to protect the recharge that we get from those uplands that Tim was talking about. And what it does is a classification means that the department has the authority to classify what types of uses or delineate what types of uses are allowed in each area, and then how much water is allowed for those uses. And then another tool we have is the critical groundwater area, which is one of the major tools we can use today to help reduce the groundwater use. So that is the authority to move or to reduce existing use. So if you have a water right, the department has the authority under a critical area to reduce that use to try to address the problem. And so then the third one, and Tim will talk a little bit more about the critical area in a bit also, but the third one is serious water management problem area, or SWAMPA. And what it does is it gives us a little more accountability. So it allows the department to require measurement and reporting on wells for water rights across the basin. So those are the three main strategies. Those are the authorities the department has that are more of a regulatory authority. There are also other voluntary things that can happen that can also address the problem, which, you know, the more voluntary action we get, the less of these that we need to use. So there are voluntary agreements where landowners can get together, take the collective use that they're entitled to, and spread it amongst each other. I don't know if you've all heard of the rotation agreement, but it's similar to that, where you just take all of that water that you're collectively entitled to and you can share among that group. That's a possibility. The other thing is we have a current conservation reserve enhancement program that's going on in the basin. We've had some interest there where folks can get paid over about a 15-year, up to a 15-year period in exchange for canceling their water right or a portion of their water right. So those are two programs that we have going on down here. Also, they're voluntary on this list. Okay. So I'll talk just briefly a little bit. Well, I'll talk a little bit about classification here the first time. So the classification boundary or the area that will be classified is this dark line around the basin here. And it's basically the Harney Basin. It goes up into Grant County up here and then down here below the lake and into this area we're at right now. Gotcha. So as I was saying earlier, classification limits any new uses within the basin. And so in what we're proposing in these rules is we are limiting to only exempt uses, which is things like house well, livestock wells, things that do not require a permit, and also non-consumptive geothermal uses of heating a house from warm groundwater. But that also means new groundwater rights will not likely be approved in the entire basin there. So for anything that's not an exempt or not non-consumptive geothermal, so things like new irrigation rights, new industrial rights, things like that are not likely to be approved in the basin. But this doesn't mean that you cannot transfer water rights. So if you have a water right, existing water right, you want to move it from one place to another, or even change the use from one type to another type, you can still do that under the classification that's being proposed. All right, next slide. So now I'm going to turn it back over to Tim. He's going to talk a little bit more detail about the critical area.
So hopefully all of you have the proposed rules packet in front of you. If you don't, raise your hand. Kate can get you a copy of it. And then there's also a map packet. Basically, it's all the exhibits that go with the proposed rules and boundaries that we show here are on these maps. You can take a look at them in depth. We also have online an interactive map that you can go look at and pull up on the web and be able to zoom in, add features like public land survey sections so that you can figure out exactly where that boundary is and how your property, if you have property, compares with that boundary. And as we go through it, I'm going to try to call out the different sections of the rules that I'm talking about as I try to explain our proposed critical groundwater area rules. And so the first section is some definitions. We're defining terms that we're going to use in these rules. We'll talk about some of the key terms as we get into the process. We've then got the administrative boundaries, and as I said, those are basically just references to the exhibits, to the actual maps. And then we got in Rule 30 classifications. That's what Jason just talked about, that restricting of what new water rights could be issued. And then we get to Rule 41, and that's where we start the critical groundwater area portion. And so one thing I want to make clear today is that when we talk about these proposed rules, what the rules are proposing is a process by which we will reduce use in the basin. I can't, until these rules are adopted and the department does the work to follow this process, we can't tell you what the regulation cutoff line will be. I can't say that rights junior to a specific date would be regulated off. What we're trying to outline here is a process by which we would get to that and make that process as clear and transparent for everyone as possible. And so now let's dive into the rules and let's talk about some of the key points that I want to make sure you're all aware of and try to explain. So on the next slide here, the first thing is the goal. So we define a goal for the critical groundwater area and for each sub area. So we are intending to stabilize groundwater levels in 30 years. So as we worked with the rulemaking advisory committee, that's a body of 32 individuals who participated in this process with us for about 2 years in preparing these rules. We heard loud and clear that it has taken a long time to get into this problem. We want to take time to get out of it and not reduce use quickly and impact the economics of the basin too harshly, too quickly. And so give people the opportunity for a glide path. So we've set the goal at stabilization in 30 years. Now in the rules, the target water level trend is the term that we're going to use to talk about the goal. So when we're evaluating the goal, we talk about achieving a target water level trend. And in the rules, we also define how we measure that. And so that's measured as zero decline over a 6-year period. So in the 6-year period preceding, whenever we're doing the evaluation, groundwater levels can go up and down, but over that 6-year period, there needs to be zero decline. And so that allows for periods of wet and periods of dry, water levels to go up and down, but over the longer term, so 6 years, we want stability. So if we go to the next slide there, Kelly. So the next thing that we call out here in the rules are regular reviews of these rules. So by statute, we're required to review the rules at least every 3 years, and at least every 10 years, we need to review the conditions within the basin that led to the critical designation. So we're specifically calling out how we'll do that, and then we call out exactly what action we'll take as part of that review. So we're proposing to present at a public meeting in the basin where we accept public comment. And so the department would come out, present the information from the reviews, and accept public comment both in written and verbal form. And then the department will take those comments, summarize them, and present them at a Water Resources Commission meeting, as well as that Water Resources Commission meeting will also have an opportunity for public comment. So you can either come comment to the department, or you could come comment directly to the commission, or you could do both. Both are an option. And the Water Resources Commission, for those of you who may not be familiar with our governing body, they are a 7-member body that essentially sets the policy and does and approves rules for the department for how the department will operate. And so that body is who actually will adopt these rules if they so choose in December when we present them to them.
Is that, excuse me, so the commission where you can actually give testimony to the commission is December?
There'll be a commission meeting in September where you could provide comment, and another one in December. We'll be presenting the rules for adoption in December, so.
But the comment period ends August 7th.
The public comment period on these rules ends August 7th, yes.
So that's not formally, how's that formally considered?
It's
By the-
considered by the commissioners as you provide that comment. It's direct to them. So your comments in this public comment period will be reviewed by the department, summarized and presented to the commission.
By August 7th
No,
for us.
yeah, any comments you present by August 7th
Presented from the commissioners, therefore, to September.
we'll be presenting the summary of this public comment with the rule package when we go for adoption in December. If you want to test it, like, if you want to provide public comment to the commission, you can do so directly at a commission meeting in September or December.
These are all their options.
I will note though that they can't take public comment on the rules in December. So that's,
Say that again?
they can in September, but I'm having conversations about how to, specific rules about the rules.
Right.
I'm also happy to, I work with HDP. I'm happy to help you figure out like where you can and cannot comment and when and how it will be considered.
Because years ago, I went to a commission meeting and it was the day that it was actually the Harney Basin rule. And I was not allowed to even say the word Harney Basin or give input in any form relating to that rule that was going to be presented by the department that day. Maybe I mixed up on the time.
Okay, well, we can definitely clarify that for you, Fred, and get you a response, and we'll make sure that's public on our website as well. But today, what we're here for, talk through the rules, and then give you an opportunity to provide comment today verbally, or there's always the opportunity to provide written comment through August 7th, or we're having other public meetings throughout the basin, and we will talk about that schedule as well. So you have other opportunities to comment on the rules.
Just for clarity, we need to get through this presentation. So if we can hold off questions until the ending, and then we'll have a full Q&A session.
So next slide, that's how we're gonna review. And then the last piece of that Rule 41 is that we divide the basin up into, or propose to divide the basin into 7 sub areas. And again, the exhibits are in your map packet. You can look at those as we divided the basin into 7 sub areas. Department staff considered a number of different things. We looked at groundwater level trends. So how are wells, or what are the trends within wells? Which wells are tracking together? We looked at hydraulic gradient, so the driving force of groundwater, how groundwater is flowing throughout the basin. And then we looked at some other like more administrative pieces. So we heard from the RAC that more boundaries would result in more conflict. And so we had originally proposed 15 sub areas, and at the RAC's encouragement, we reduced that down to 7 to try to reduce the number of boundaries. We also thought about complexity. Again, more sub areas, more boundaries, more complexity. There's more opportunity for confusion as you work through the map and try to figure out which sub area you're in. And then the last one was related more to voluntary action. And so we heard that having larger pools of water right holders together allowed more opportunity for users to come up with solutions to the problem in a voluntary fashion rather than through this regulatory process. So all of those considerations were taken into account. And at the end of the day, what sub areas allow us to do is to target our regulation at the areas with the most severe declines, while trying to limit the impacts on other areas, while still achieving the goal. And so that was the purpose and the intent of sub areas, and why we divided it up that way. So if we move to the next slide, I want to start talking about how we get into the actual reduction of use. So the first term I want to talk about is permissible total withdrawal. That's a statutory term, and we're defining it here in these rules to mean the permissible total withdrawal. It's the annual volume of groundwater that the department believes is going to achieve the groundwater level trend. So our goal by 2058. So we're proposing to solve this problem by 2058. So in 30 years, and we're proposing to start in 2028. And that happens when we follow the schedule of reductions that we're outlining in these rules. So we'll talk about the schedule here in a minute. The values are presented in acre feet by sub area. And as I said, they're laid out here in Rule 50. And so if we go to the next slide, I've got a table of the actual proposed permissible total withdrawals. And here on the table, we list estimated pumping from 2018 by sub area. We list the proposed PTW, and then we list the difference between that. And as you can see, basin-wide, it's about a 35% reduction in pumping is what we're proposing. And then each sub area is broken down in there. Now, one thing I want to point out is that the permissible total withdrawal, as we were working to calculate it, the department used the USGS groundwater model that was produced as part of the groundwater study in order to try to identify the maximum amount of pumping that could occur based on the parameters we had specified. So the 7 sub-area boundaries, the goal of stabilization in 30 years, having a schedule for reductions, and basically taking all those inputs and then staff developed software in order to have the model run iteratively. And we've run hundreds of simulations to come up with these permissible total withdrawal values that we believe will stabilize groundwater levels and maximize the amount of use that can occur. So in an attempt to minimize the amount of economic hardship that will be caused by reducing use. So that's how we set the permissible total withdrawal. So now I want to talk about how do we get from or how do we actually get to that value? How do we schedule out those reductions? And how do we identify what we're currently using so we can know how much to reduce from? So if we go to the next slide, I want to talk about initial allotment. So Rule 60 is where these or where this process is laid out. And the intent of this process is to provide as much water to groundwater users who have been beneficially using their rights. So there's currently about 100,000 acres worth of groundwater right, or about 300,000 acre feet of water in groundwater rights on paper. we estimated in 2018, only about 135,000 acre feet was being pumped. So less than half of the paper water is actually being used. And what we didn't want to do was reward groundwater right holders for essentially speculating on water. What we want to do is make sure that people who have been using water beneficially to make, a living, as many of those people get water as possible and try to reduce the actual economic harm. Because we believe if you haven't been using the water, you haven't been benefiting from it, you shouldn't benefit simply from having the piece of paper. That's not the intent of it. And this allotment process will basically be issued as an order that reduces the quantity of water that can be pumped under a groundwater right. And so there's 3 different categories of rights I want to talk about, and we'll get into each one. And I want to start with irrigation. So if we go to the next slide, Kelly, what we're proposing for irrigation rights is to reduce the duty on each groundwater right from whatever its current value is to 2.5 acre feet. So all but 5 groundwater rights in the basin have a duty of 3 acre feet. And what we're proposing is to reduce that from 3 acre feet to 2.5. Now the duty, if you don't know what it is, it's the volume of water that you can apply per acre under that groundwater right. So right there, what we're trying to incentivize is conservation, as well as to make the amount of water we have go as far as possible to as many users as possible. And so that 2.5 number represents a reduction in use for every groundwater right holder in the basin. The second thing we want to do is we want to consider the historic beneficial use. So what have people actually been using? And we're proposing to look at the 5-year period from 2020 to 2024 and identify what actual acreage has been irrigated and use that to allot water rather than just looking at the paper water rate. So here I've got a figure. It's a picture of a field. You've got a black line around the outside. That's the place of use. That's where you're legally authorized to apply water under this water right. And then inside of it, we've got a pivot, and it's obviously green. It's being irrigated, and the corners are all brown. And so you've got 160 acres of place of use, paper water, but only 125 acres has actually been irrigated on a consistent basis. So what we're proposing to do under this process is take the 125 acres times the 2.5 acre foot duty to give you the total allotment of water for this groundwater right of 312.5 acre feet. And so again, the intent of that is to not reward the person who hasn't been irrigating their corners simply for owning the groundwater right, and to take that water that could have been used on those corners and distribute it to someone else who's been actually beneficially irrigated. So that's what we're proposing for irrigation rights. The next type of right are municipal rights. And for municipal rights or quasi-municipal, think your 2 cities, right? Burns and Hines are your primary municipalities with these types of water rights. What we're proposing is to allot them 110% of their highest single year use between 2020 and 2024. So I've got a graph up here. This is the actual pumpage reported to the department by the city of Burns for the years 2020 through 2024. You can see that 2020 was the highest year of use at 1,250 acre feet. What we're proposing is that what they would be allotted under these rules is 1,250 plus 10% for a total of 1,375 acre feet. And then we're also proposing that every 6 years, as we go through our adaptive management process, which we'll talk about in a moment, that we would reevaluate that and adjust the city's total allotted water up or down, again, based on the same formula, but using the previous 6 years. So this limits the city to a growth rate of no more than 10% growth in water use per year. What this does also is it prevents the city from rapidly accumulating and using water and requiring regulation of other groundwater rights. Obviously, the city is important in providing water use for water for human consumption is a priority. It's called out in statute. It's very specific. And so we need to provide that water for human consumption for a municipality. But we want to do it in a responsible way that doesn't reserve a lot of water for a municipality that may or may not use it. And instead make that available for beneficial use, and again, trying to limit the amount of economic harm that are caused by these rules. So that's how we're proposing to deal with municipal and quasi-municipal rights. And then the last sort of group of rights I want to, if we go to the next slide there, are all other right types. So you can think commercial, industrial manufacturing, wildlife, pond or reservoir maintenance. There's a variety of different types of rights that are groundwater rights that we're going to need to look at. And there's only, I believe there's about 40 of them in the basin currently that we'll have to review. And what we lay out on the rules is basically a process by which we identify their historic beneficial use and allot water. And so the considerations we're going to look at are the limits of the groundwater right. So what does the actual paper say they can do? What has their historic beneficial use been? Can we calculate that? Can we get records for that? And then whether or not water use is physically capable of being pumped and put to use, right? Do they actually have water use infrastructure? Do they have a pump in their well? Things like that, to be able to identify if they've been beneficially using. And then we give ourselves some broad authority to look at any other factors that we deem necessary in order to establish that historic beneficial use. So other items that we may not have considered, but we need to consider in order to allot water. And so that's the process by which we figure out what is the current use in the basin, and what's actually being pumped. So from there, we can figure out how much we need to reduce. So if we go to the next slide, I want to get into the schedule for reductions. So scheduling reductions, we basically take the initial allotment, right? So how much is actually being currently used? We subtract the PTW, and that gives us the volume of water that we need to reduce. So how much reductions need to occur? And laid out in Rule 70 is this process. And one of the key things we wanted to point out is that junior rights are curtailed first. So when we get to this process where we're actually reducing use, we'll be regulating off based on prior appropriation, and the junior rights will be fully curtailed first. And so that process can only be enforced after a contested case hearing is complete. So these rules propose the process by which we reduce use. The contested case hearing is the opportunity for the department to present its case before an administrative law judge, and for the groundwater right holders to also present their case to the administrative law judge and defend themselves against the actions of the department. And so that's a process that's required by statute. And the department cannot enforce any of these regulatory orders until it's complete. So that's built into the process and called out specifically here. So the next slide, I want to start talking about the schedule for reductions. So in this schedule for reductions, we call out one sub area specifically and give it a different schedule from everything else. And that's Weaver Springs. Weaver Springs is an area with the most severe declines, both in magnitude and rate. And in working with the RAC and going through our process, we identified that by putting them on a different schedule, we could have some substantial benefits for other users in the basin, domestic well owners, or discharged in streams and springs, as well as to minimize the amount of reduction that has to happen in neighboring subareas in order to help recover water levels and stabilize water levels in that very deep cone of depression there in Weaver Springs. So for all other subareas, I have a figure here that shows what the schedule is. And basically we call it the 40, 30, 15, 10, 5 schedule. And so what this figure is laying out is in the first bar, this is 2028, that's when we propose to start. We're going to have identified an initial allotment. We'll have gone through that process to figure out what is the actual current use and to have limited all water rights to that. We then need to start reducing use. And so the orange bar shows the amount of total reduction that's implemented at that point. And so in year 2028, we're proposing to take a 40% cut of the total reduction. So 40% of the total reduction will be applied in 2028. Then we'll wait 6 years. That gives some certainty to groundwater users. They know no more reductions are coming until 2034. In 2034, we're proposing to then increase the total curtailment by another 30%. And so now 70% of the total reduction will be implemented in 2034. And then we add on 15, 10, and 5 to get to the total reduction here in 2052. I want to point out the numbers on this figure are purely for illustration. They don't represent a sub area. We made the math simple using 0 through 50, and our percentages were able to come out easily. So that's the schedule that we're proposing. Now that schedule can be adjusted by our adaptive management process, and that's what I want to talk about now. So if we go to the next slide, Kelly, adaptive management is called out in the rules to Rule 80, and it's essentially our process for evaluating progress. So how are we doing? The department has never done this before, an adaptive management process. No other critical area has this built in, and we believe that it's the right thing to do to provide a glide path and an economic adjustment period for people, but also to actively manage the basin in a way where we can respond to conditions rather than simply laying out a path by which we get to a final reduction number. And so the first thing we call out in this adaptive management process is we'll do an evaluation in 2027. And we'll delay reductions if these two thresholds are met. So if groundwater levels, the median groundwater level in a sub area is at or above its 2022 levels, and if the target water level trend shows zero decline. So if water levels are stable and they're at or above 2022 levels, then the recent wet years have caused recharge. Perhaps pumping has changed since 2018 with the last year we estimated groundwater use. And perhaps farmers have, who are the bulk of the water users, have gotten together and done voluntary action to try to reduce use and try to solve this problem ahead of us. And if that's the case, then we'll delay any scheduled curtailment until the next adaptive management checkpoint in 2034. So we want to reward action that solves the problem ahead of regulatory action. Otherwise, if those conditions aren't met, then we'll adhere to the reduction schedule, and that's what would be implemented. So another key point I want to call out here is that data is really important for adaptive management. We have to know what the groundwater level conditions are within each subarea in order to be able to evaluate if we're on track or not. And so we're specifically calling out that the department has the authority to go out and measure wells in order to maintain this process. And when I say wells, I'm saying any well on a water right. And so we would be able to go out and measure those wells. The department maintains an observation well network of about 100 wells that we measure quarterly. There are also permit conditions. So on certain water rights are required to measure a static water level each March and report that to the department. And so we use that data as well. And so this is giving us the ability in cases where a user is regulated off and no longer reports water level data to us, that we can go out and continue taking measurements in those wells and continue to track conditions over time. Now, if we go into the next slide, I want to talk about adaptive management checkpoints, which is where we're actually evaluating that progress and what we're going to do. So in the rules, we call out 4 adaptive management checkpoints. These are in the years immediately preceding scheduled reductions. We need to have time to be able to evaluate conditions and make announcements about what we're going to do with regulation in time for decisions to be made about water use in the next year. We don't want a farmer planting a crop and then being regulated off. That doesn't make sense to us. It certainly doesn't make financial sense to a water user. So we're going to evaluate the median water level for each subarea, and we're going to compare that to the modeled trajectory. So in the map packet, there are some modeled trajectories. And what these are is essentially figures that were produced using the groundwater model again, and they outline what the expected water levels, water level trends are over the 30-year management period. And so what we're going to do is we're going to compare our actual measured data with our modeled path for achieving success. And if we're on track, we're not going to adjust anything. We're going to continue with our scheduled reductions. And that's because the changes that we're making are having the expected effect. Our model is right on the money and we're getting where we need to be. if water levels are higher than expected, so maybe wet years, maybe more voluntary actions have reduced use, and water levels are higher than expected, we want to reduce and have fewer reductions implemented at that checkpoint. So we can reduce the quantity of reduction or the quantity of curtailment that's implemented at that scheduled period by either half or completely. So if water levels are substantially higher than expected, we can implement no reduction at that checkpoint. If they're doing well, but not so high that we're able to reduce reductions completely, then we'd implement, basically cut those reductions in half. And then on the flip side, if water levels are lower than expected, so water levels are not improving and are declining more than we had modeled out in this modeled trajectory, then we can implement accelerated reductions. We can accelerate reductions by either 50% or 100%. So we can go half again as much or double what was scheduled in that period. So then, as part of this adaptive management process, we are proposing to then meet in the basin each year or each adaptive management checkpoint year to announce the changes, and we'll also accept public comment on those changes. And so that's the process of adaptive management. And as I said, it's laid out in Rule 80 here. The next step, after we've gotten through all of this, all of these adaptive management checkpoints, is now we need to evaluate for success, right? So we've managed the basin for 30 years. So now let's evaluate success. So in the rules, we specifically call out that no sooner than 2058, so 30 years from the time we're proposing to start, we're going to evaluate the water level trends and identify if we've met the goal or not. And then depending on the results of that analysis, we'll potentially take further actions. And we're specifically calling out that if we're unsuccessful and pumping exceeds the permissible total withdrawal, so we haven't implemented all the reductions, right? We have this process by which we could not get to full reduction. Then if we haven't achieved the goal, we can continue to implement reductions in order to get to the goal. If we're unsuccessful, so water levels are still declining, and pumping is equal to the permissible total withdrawal, so we've implemented all the curtailment that is allowed, then the department will need to do rulemaking in order to adjust the PTW to try to solve the problem. And then the last step is if the process is successful, so we've achieved our goal, and pumping exceeds the amount of or that volume of PTW that's specified in the rules, means we didn't have to implement all of the reductions. Then the department will do rulemaking to adjust the PTW up to the actual use at that point. And so that is to provide certainty for the water users who are still pumping that they won't be under threat of regulatory curtailment anymore. And so that is the process for our critical groundwater area rules. And again, this evaluating success is the last essentially section of that Rule 80, which is the overall adaptive management process. So now I'm going to turn it back over to Jason and let him talk about the serious water management problem area, and then we'll jump right into Q&A.
All right, as I talked about earlier in the presentation, this is the third tool that I talked about when I initially started speaking. So this again looks familiar to the classification boundary, and the reason is it's the same boundary as the classification. So we're using just for consistency, using the same boundary for the serious water management problem area. And so what the serious water management problem area does, it gives the department a more broad authority to require measurement devices. So the department already has an authority to require measurement devices on any well or any surface water diversion they need data on. This does it across the basin because of the critical area and then the upland recharge and all of that. Together we need more and more data to be able to evaluate whether we're on track or not. And this helps us do that by March 2028, requiring all groundwater right rights to be measured. So each well on each right would require a measure device or fertilizing flow meter. So the flow meters, they all need to be installed according to the specifications from the manufacturer. And maintained in good working order. Also, they need to be accessible by the department. So we can check, make sure that they're operating correctly. And then, also if for whatever reason, somebody decides they just aren't going to install on a well that's being used. We would, work with them, try to get, some voluntary cooperation there. If that doesn't work, we do have an enforcement process that we can use that could lead to, assessment of civil penalties. We typically don't need to do that, largely because, well, at this time at least, and for the last few years, we've had a cost share program that will provide 75% reimbursement for, installing, flow meters. That program has good funding right now, and we expect to continue to be able to use that into the future. We don't know how long it's gonna last, but it's been going pretty strong, and we probably put out, just off the top of my head, maybe $60,000 worth of flow meters in this basin in the last year. People are taking advantage of that program. Another thing I'll point out is most groundwater rights in the basin, probably 70 to 80% anyway, already require measurement on the water right. So most wells already have measurement. And so it ends up being approximately, that aren't already required, approximately 300 to 400 wells in the basin that don't have that requirement on the water rate that we'll have to measure. Like I said, anybody, whether it's required already or not, can take advantage of the program for cost sharing. So, as part of this program, as you install your measuring devices, and start recording use, that use needs to be manually recorded every month. We'll get to questions in a minute, Mario. And then reported annually as we go through each year. So by the end of each year, the recorded monthly measurements from the flow meter will need to be reported to the department. And then if for whatever reason, meter becomes non-functional, broken, battery dies, whatever the case may be, those non-functioning meters need to be reported to the water master within 48 hours of the discovery of, the non-functional meter. And then once that is reported to the water master, you have 60 more days, you can continue to use the well, to, get a new meter on, get a new battery in it, whatever you need to do. And then during that 60 days, you'll still need some sort of measurement. And that, those options are laid out in the rules. One of which is most common, is power meter readings on the well. You can take those, we can calculate approximately how much water has been used through that system. And then once that meter is compared, that can be reported to the water master within 48 hours, and then a record of the repair, and that we're good to go on that well. All right, so that's the end of the presentation. We're happy to take any questions folks have.
Just a quick thing before we go into the Q&A. We ask that if you have public comment, not a question, you wait until the public hearing portion of this. So after we finish up with Q&A, we'll take a break. We'll come back. Kelly will go over a spiel that he's going to give on how the public hearing will go. People have the opportunity to sign up and give that public comment. So if you've got like a burning comment you want to say now, write it down, jot it down, keep it in your memory bank, and hold on to it for that public hearing portion. But for now, we're just doing Q&A. So now's your opportunity to ask our staff.
All right.
Point of clarification, I think on the previous slide, we are to report annually for the year on December 31st. That's kind of hard to do. How are you going to do December? Can we select, let's say by water year, October to September?
Yeah, so,
Variability.
yeah, so for brevity there, we say it has to be reported by December 31st. But the time frame is actually laid out here in the rules. And the period of use that you have to report is in rule, what is this, 110? Section 5. And it says that you'll report the water used between November 1st of the preceding year and October 31st of the current year.
Water.
So October 31st is the end of the irrigation season here. You then have from October 31st to December 31st in which to report to the department the use that has been measured and reported over that 12-month period.
So it's not quite the water year, but it's a month extended, but yeah, correct.
John,
You said, we have the 7 sub areas and the idea was to, those that are in the worst shape would be restricted back the worst, and we as a RAC asked to see a comparison of the what Water Resources proposed versus cutting back lower Blitzen, which isn't triggering anything. But yet it gets 39% cut back on like one of the healthiest sub-basins. Was there a reason the memorandum, was not implemented? It looked like there'd be fewer, domestic wells go dry. And almost no difference with stream flows or spring.
yes, that's a really great question. And what John's referring to is we've posted on our website a memo coming out of the last RAC meeting. We had an alternate proposal from a member of the RAC asking for less curtailment, essentially in the lower Blitzen voltage sub area, which is here down south of the Malheur Lake, and implementing more reductions up in the northeast Crane sub area, so north and east of the lake. And that memo is available for you to look at. It outlines some key differences between the two proposals in water level trends, in impacts to domestic wells, and in impacts to natural discharge to streams and springs, and then to native vegetation, those groundwater dependent plants. And essentially what we found is that by shifting curtailment from lower Blitzen up into northeast Crane, it requires more basin-wide curtailment. So overall, there's less pumping basin-wide in order to achieve the goal still. So because it's all one groundwater reservoir, groundwater is connected, in order to stabilize groundwater levels on the time frame that we've outlined, if we move more curtailment into that northeast area, we have to implement more reduction overall basin-wide. But it is a really good point, John, and I would encourage those of you here to provide either written or oral comment on that, and to take a look at that memo on our website, because it does provide some key data there. So thank you for bringing it up.
So how many wells were tested in lower Blitzen?
I don't have that off the top of my head. We've got a water level trends analysis posted online that lists the water level trends by sub area, as well as all of the wells that were evaluated as part of that trends analysis in each sub area.
And it shows exactly which one it was.
It gives you the well log ID for each well that was included in that evaluation. So you can see the well log ID, and then I believe it's also linked to our groundwater information system. So you can click on that link and go immediately to the page with all of the water level data that we have in our database for that well.
Okay, 'cause I don't know anybody in lower Blitzen that is losing water.
Correct me if I'm wrong, the difference, you said that it means a little more curtailment basin-wide. If I'm understanding, is the difference, it's a total of 35% over these 30 years, curtailment basin-wide versus 37% if we use this alternative.
I believe so, John. It's been a few days since I've looked at those numbers specifically, so I don't want to misquote it. But it's in that order of magnitude for sure.
That 2% is then could split 7 ways, you got 7 basins.
I mean, it's actually split one way, and that is more curtailment in Northeast Crane. And less curtailment, more Blitzen voltage, so.
So Fred had a question and then the gentleman there.
Yeah, so just to be clear, highly recommend you look at that memo, and we would love to hear comment specifically about that alternate proposal. Because the folks in this part of the basin are definitely impacted by that, and we would love to hear your opinion.
Mine was way, yeah, mine's a little twist on it. Off John still, so if anybody wants to go ahead.
So what your data's saying that is, the lower Blitzen's feeding the big puddle, I guess, all the straws are coming out of it. Our water was pumping with no static and drop at 70 feet. Ample amount of water is affecting the people pumping 800 feet deep,
Yeah, it's all
70 miles away.
It's all connected, so to stabilize groundwater levels basin wide, we have to make change across the entire groundwater area.
You're positive it's.
Yeah,
Very trained.
You either call it something otherwise, I guess, and I think a lot of other research has said otherwise, and I think a lot of other research has been presented from you guys otherwise, and you threw it all out.
So we're using the best available science that came out of that collaborative study between the USGS and the Water Resources Department.
We had to measure our statics forever, in our region showed a significant drop. In some cases, we showed 3-4 inches rise in static rises. And we're very in front of those lacking water zones.
So what I'd refer you to is that water level trends analysis to look at what the actual calculated trends are for this area. And there are, over the entire sub area of the lower Blitzen voltage, there are declines.
So when we have more water, then people have less water.
I'm not sure I understand your question.
Our statics have been on the rise. I know because I paid for the static measurement and they've rose the last 3 years. People are losing water because of that.
I would not say that is
I'm just trying to make a correlation between the water bearing zones that we're talking about, and if they're stolen puddles, I don't understand what they is.
So I'm not sure exactly how to address your question.
There is one aquifer.
Yeah, so it's one groundwater reservoir, that's what's defined, and then we look at wells within each sub area. We evaluate trends. So over the last couple of years, yes, some wells have been recovering. Many wells have still been declining, even with the large quantity of recharge that's occurring.
I was just saying, like, within that region, it seems like they're all recovering.
Sure, and again,
there's ample.
Again, I would point you to that
They're
water.
borderline artesian wells. And it's just, it seems to be like we're being regulated on an area. I mean, to pull the yard 2,200 gallons an hour of the ground at 60 feet, that is an immense amount of water. Absolutely, no one's being affected by that. And maybe we stance, I guess, and to say how that has an impact on Sandy Canyon and Riley, anyone else, I guess is where, that's actually.
Yeah, so what the groundwater model allowed us to do was to test out how changes in use. So by changing the way water is pumped out of that modeled system affects other portions of the basin. And our water level trends analysis, which looks at actual measured trends, and I believe the data was updated to include March of 2024. So we have March of 2024 data included in there. And we still saw areas within the lower Blitzen voltage that were declining. Some were recovering, but on the whole, the subarea's average was still declining. And the median groundwater level was declining as well.
I see. I span across about like half of that region. Okay, quite a ways, and I guess where I see if I have a gain in static different sectors where that water obviously comes from I understand all goes to the same area. I don't know what level in the, within the geographical phase that lies building in, I guess, but.
Yeah, so again, I push back that information. And encourage you to provide comment, those comments in the public hearing. So Brett?
Well, mine fits here then a little bit because you guys, your kids, a lot of measurements to try to figure out or just justify what you believe is going on, but what happens? Because then you threw it all in the model. And models are based on assumptions. And it's only as good as the data and assumptions made and different methodologies of correlations and whatnot. So what happens on a review after a whole bunch of people are curtailed and everybody gets even more data and you find out that the model isn't right, that the model doesn't correlate to all of your measurements when looked holistically and comprehensively. So what happens then? Because there's people that might lose, I don't know, $800,000 like us, or people, some people that have been millions. When it's wrong, when it's wrong. So what process are you going to use to test the test? Meaning to test whether the model is even relevant to the measurements across the board. I mean, I'm serious about going that far, but I dealt with models and most of them there has to be a lot of them. Watch your weather models and they'll overlay 200 models and they'll all be saying something different. And then you go back and you look at it and test the assumptions and see what happened on the ground. So how do you guys put all your eggs in the model after working really hard to do comprehensive static level measurements and that's when it kicked to lower down or more Blitzen voltage based on a model when there, my belief, this is input, but there is no measurable or documented linkage. It's correlated by static levels, but how do you test where the model sent you guys to some really crazy places?
So
Donner Blitzen, Nora Blitzen, and Wiley, so Upper Silver.
So the model was built using data from that study, and then it was calibrated. So the data that was put into it was stream flow measurements, spring flow measurements where we had them, and water level data from 1930 through 2018. So we used a substantial amount of data to calibrate the model. Since using the model in this process, we have then used that model to predict water levels in each sub-area, and we've compared them with actual measured water levels. And we believe the model is tracking fairly accurately with those model projections. One of the key assumptions that I think is worth pointing out to everyone is that the model assumes average recharge. So over a 1 or 2 year period, that could be wildly inaccurate because we've had a few years of drought recently, and we've had a few years of excellent water recently. So over a short period of time, those are gonna over a period of time, those are gonna average out. And so that's the key assumption.
Assumes linkage, in my opinion, between different aquifers. And when you had 15 sub areas, they were correlated a little bit by aquifers. So the assumption there on the model that isn't tested fully yet is the linkage of water moving from Lower Blitzen to Crane. or river spring, and that's stretching the model quite a way. So how do you test that?
So I am not the hydrogeologist to explain how we would go about testing that or how we would build it. So I can't answer that question directly, but so that sounds a lot like a public comment to me. So I would encourage you to provide comment on that during the
Well, it's,
public
it
hearing.
could be a comment, but it's a question on
Would it
how
be
you're gonna
answered?
test the model.
What?
Would it be answered in public?
No, we can't answer questions.
No,
in
I
public comment.
understand.
We can definitely take that, we can definitely take that down as a question and we can post it to our website, after answering it. Okay. So. In the back.
Exactly, Washington Council paid for a study, because they were getting concerned, this situation exactly. In that study, and I don't know all of the individual in fact, but absolutely there was evidence of soil structure, stratification, subsurface in the Weaver Springs area. And the Buchanan Crane area that was causing a lack of water within those regions. So again, it comes back to a question many people have had, is this business of one aquifer in the basin. That study very clearly showed, that was not the case. So did you guys take any of that information into consideration?
That was all considered as part of that USGS collaborative study. Absolutely.
Well, how did that's been one of my big questions through this whole thing, is how are we calling it basically one aquifer underneath all of this, and it's very clearly not.
So I can only point you to what the scientists, the best available information that we have, that conclusion was, is that it's one groundwater reservoir. Mario.
I think it's the preceding slide to 35. Don't know what I'm talking, I forgot what I was gonna talk about. But we already did that, okay. The USGS 2020 study, which is Gingrich et al., had a figure of a paper deficit of 134,000 acre feet. The next USGS study, which is Garcia et al., estimated a paper deficit of 144,000 acre feet. On the previous slide, there's a number of just 104,000 acre feet. What I noticed from the 2022 study, which is Garcia et al., when they were doing water withdrawal, they were making the assumption of full duty. Those allocated paper rights, full withdrawal on those rights. However, not everybody spends at the same time or uses the same amount of water. So is the 104,000 acre feet estimate that the department is making, is that more accurate? Are you happy with that number?
So what you're comparing there are apples and oranges. So when they're looking at paper water rights, and I'm looking at paper water rights, I'm looking at only within this lowland area. And what we're comparing is the authorized use with recharge. We're not comparing that to estimated use.
So
So
recharge rate is more like 30,000, there it is, 29,200. Is that or 28,200?
no, so nowhere on here do I list the recharge. What I'm
Oh.
showing is the difference between recharge and actual pumpage in this column, and between recharge and authorized use here. And so you can't back into that number. I'd have to
Okay,
go in and pull that in.
okay.
What was the proposed reduction again on regions of the Bureau Code?
We can pull that up. No, it's okay. It's also, yeah,
So we're looking at a 39% for lower Blissman. Or sorry,
yeah.
I gotta reduce 40% from your. That's 7 off of 2,000 gallons, that's 70 feet.
That is what the proposal says. That's what you're saying. That's what the proposal says. That way. And again, we would love the feedback and the public comment. Yeah.
At the end of 24 years.
Other questions?
Harmony?
Yeah, I wanted to kind of introduce myself before. I'm Harmony Bright. I'm working with High Desert Partnership. So I'm gonna help anyone really, but the folks in Ryan County make comments on the rules, understanding that they're pretty complex and maybe you haven't given comments on a rulemaking process before, but I'm here to like help you think through what comments you might want to make and be a resource to you. So I've got information in cards that I'll give to you at the break, assuming you have a little break. But I'd love to help you figure out. Make effective ones. Turn this window.
So we have about 5 minutes left. If there's an additional last question.
I have a quick question.
Yeah.
You're saying it's all one big pool, but you have your sub areas dividing it, and then earlier in your talk, you mentioned. In certain sub areas in 2028, if they show that there is not the drawdown that. Or maybe it's up higher, then maybe there would not be any regulations, so. Does that mean that even though you say that you're gonna regulate? Because of the other sub areas might be declining, if this sub area is showing stabilization and you still, then that sub area would not.
Correct. So we want to manage the basin holistically and try to stabilize groundwater levels throughout the basin, not just in one specific area. But if one area achieves the goal faster than another, it could receive less curtailment or under this, no curtailment in 2028 if these,
Even if another sub area.
even if another sub area is declining.
Oh, it is divided.
Yeah.
Okay.
Absolutely. Thank you for that question.
So on the lower blood zone. 39%, in 2028, it's 40% of the 39%.
Correct.
So 8,300 acre feet authorized use from 2018.
Correct.
And so the cut. The cut would be what for the 16%? The actual cut would be 16%,
Correct. In 2028.
2028. So. What would? Does that mean that? Static level and. Lower Blitzen voltage would have to be 16% higher to achieve no.
No, that's where I'd refer you to the figure in the exhibit, the map packet. There's a figure specifically for lower Blitzen voltage. And you can see the dark blue line in this packet is the median groundwater level trend, and we expect that even with that curtailment, the median groundwater level trend is expected to go down about another foot before it begins to stabilize and then stabilize over that entire period.
What page is that?
There aren't page numbers on this, but it's exhibit 14. It's right after Dog Mountain and right before Northeast Crane. Because I believe they're alphabetized.
So,
So that dark blue line on that figure is the median groundwater level that we are projecting with the model. And so it's projecting that from 2028 to about 2034, groundwater levels will decline by about a foot over that period. And then with the additional curtailment added on in 2034 and at the other points, we will see groundwater levels stabilize over the long term through the end of the century. Yeah.
So, understand this 2028. For that first reduction, you're gonna look at the last 5 years, like the previous 5 years. Was it 2022 through?
It's 2022 levels and then the target water level trend, which is a 6-year calculation. So it'd be the preceding 6 years.
Okay, and so looking at lower Blitzen, we're saying if that trend is
0.
if it's 0, that's definitely higher than expected, so there would be like half as much reduction as we're talking.
If we're also at or above 2022 levels, there'd be no reduction.
So we have one question from the gentleman in the red who's been patiently waiting, and then we're gonna stop.
Could you, clarify what, prompted the combining of these sub-areas from 15 down to 7? And how do we locate the science that was used to then combine these sub-areas?
Yeah, so the 15 sub-area proposal was based on some key criteria, and one of those criteria was looking at cones of depression using groundwater level contours. And when we went to combine sub-areas, what we did is we dropped that criteria for creating sub-areas. So we basically stopped looking at that specific criteria, and we began to consider other factors. NDVI data, so how green or like the extent at which surface water is making it across the ground was included. And then we began looking at those administrative reasons that I mentioned earlier. More boundaries leads to potentially more conflict. And then the desire to have more groundwater users grouped together to allow for more options for voluntary agreements. And then again, trying to reduce complexity. So instead of having 15, go to 7.
The reduced complexity though, doesn't necessarily follow the available water that are in certain subbasins. You can get one subbasin that's pretty healthy, you combine it with a full subbasin, and it really degrades water options.
Absolutely, I think that's a great public comment, and I'd love to have you provide that at the proper time. So, but I don't disagree with you in any way. It's absolutely true. By combining areas into larger sub areas, the whole sub area is now being evaluated as opposed to multiple individual smaller sub areas. Yes, that's exactly right.
And we'll have that public hearing recording here in just a few minutes.
Just a few minutes, and you can absolutely provide that feedback. Yep.
Cool.
Yeah, so we'll turn it over to Kelly.
We're gonna take a break.
We're gonna take a break.
Yes, 15?
Do we get 15 again? or-
No, we do not. We get 4.
Great.
It's
Going on?
It's a cookie break.
Take a cookie break, maybe stretch, and